Hello guys, my name is Preston Thomason, and for my question number 7, it asks, consider the differential equation dy dx equals y squared plus x squared over 2x squared, for which y equals -1 and x equals 1. Part A asks, use Euler's method with a step length of 0.25 to find an estimate for the value of y when x equals 2. So here we have Euler's equation, which is y sub n equals y sub n minus 1 plus h, and h's step, which is 0.25 given in the question, times f of x, which is, you use the x from the previous equation, and then y of the previous equation as well. So the first step is, since we're taking by step and we're trying to get to for when x equals 2, it looks like this, and I'm about to explain it here. So you have y equals -1 plus 0.25 times 1 squared plus -1 squared over 2 1 squared. And the -1 right here comes from the original equation or given coordinates with the y unit -1 plus 0.25, which is the step, and plus the x and y's from the given coordinates. So all we're doing is just plugging and chucking in the Euler's equation. And then for y, you will get 0.75. Now, for you to keep, it's a repetitive process. So you do this again for part 2. And now you have y equals -0.75 because you used it from the previous answer. So for Euler's equation now, it looks like -0.275 plus 0.25 times the quantity 0.75 squared plus 1.25 squared over 2 times 1.25 squared. And you use your calculator and you get -0.58. So now we're only at 1.25, so we have to keep going. We have to get to 2, but using a 0.25 step, so that's 3 more times. So the next time, we're using our previous y value, which is -0.58 plus 0.25 times the -0.58 squared plus 1.50 squared. We get the 1.50 since it's the next step. And that's over 2 times 1.50 squared. Once again, using the graphing calculator, you get -0.44. Now for the last time, you have y equals -0.44 plus 0.25 times the quantity of -0.44 squared plus 1.75 squared over 2 times 1.75 squared. And your answer is -0.3. It helps to show when you put this in a table, such like this, where you get your initial condition up here with x equals 1 and then y equals -1, and you keep adding the step of 0.25 right here, and then you see the corresponding y values. And as you see, when x equals 2, y equals -0.3. Okay, so on to point B now, or part B. And part B is asking, or B sub 1 is asking, solve the differential equation giving your answer in the form y equals f of x. So for this one, we're going to use substitution using the V method. And for that, you have to have a homogeneous differential equation. And that's when all of the powers are equal. As seen here is y squared and x squared, and you have x squared in the denominator. So this is able to use this homogeneous differential equation method. And in this method, we set y equals to vx, and then v equals to y over x, and then dy over dx equals v plus x dv dx. To also help us, we rewrite the equation as dy over dx equals y squared over 2x squared plus half. The next step now is we plug in these values. So for dy over dx, we have v plus x dv dx, which is set equal to half v squared plus half. And the v squared comes from, because when you have y squared over x squared, it becomes v squared. Following, we have x dv dx, which equals half v squared minus v plus half. I just subtracted v from both sides. And then I factored out the half, which equals x dv over dx equals half times the quantity of v squared minus 2v plus 1. That's the difference of two perfect squares. So then I can set that equal to half times the quantity v minus 1 squared. Next, we separate like coefficients, or like variables, my fault. And then, so we divide both sides by v minus 1 squared, and we multiply both sides by dx and to divide by x. So we get 1 over the quantity v minus 1 squared dv equals 1 over 2x dx. Next, we take the integral of both sides, and we get half ln of v minus 1 squared equals 2 ln 2x. And using the properties of logs, we are able to become ln of v minus 1 is equal to ln of 2x squared, because when you have a coefficient in front of the natural log, you're able to put it to the power, and the square root and the square cancel out, and then it becomes 2x squared. So then we have ln v minus 1 equals ln 2x squared. Now, continuing with this properties of logs, we can cancel out the ln's by raising everything to the e, or raising e to the what we found, and then we get v minus 1 equals 2x squared. Next, we resubstitute what we had up here with the v equals yx. So you get y over x equals 2x squared plus 1. And then since our question wants it in the form y equals f of x, we get y equals 2x cubed plus x. Okay, we're almost done. We're on the last section of this question, and B subsection 2 is saying find the value when x equals 2. So you have y equals 2x cubed plus x, which we found in the previous part, and we just plug in 2. And then once we plug in 2, we get y equals 18.